So section 4.2 goes over the law of sines. And the law of sines is nicely summarized right here. Basically what it says is that each of these ratios is proportional. That is, the sine of an angle and the length of its opposite side are going to be proportional to the sine of another angle and its opposite side in a triangle. Now, to use this to solve, what you're going to need to know is a known side and angle pair. So one of these ratios has to be known. If you don't know a complete ratio like that, chances are you probably have something like a side-side-side case, in which case you don't have any angles, or a side angle side case. Both of these would mean you need the law of cosines, but that's the next section. So for now, we're going to work on this one, this section, and we'll start with this problem right here. So the length of a proposed span ski lift from A to B, that's going to be from here to here. Got to figure that out. Now, a surveyor measures some angles, and let me just kind of put those in for you here and here. This is a 25-degree angle. This is a 15-degree angle. We want to know the length of this side, basically the length of the ski lift. So, okay. You got to do a little figuring out of some things indirectly. It'd be nice if I had an angle and opposite side pair. The only side I know is this side, so it means I got to know this angle. Well, if I knew another angle, then I could subtract from 180. The good news is I do know another angle. This much is 25. And the total has to be what? What's this?
180.
180. So 180 minus 25 gives me 155. And with that added together, I get 170. So that has to be a 10-degree angle. And that's what I was looking for. Looking for the measure of that angle so that I have an angle and opposite side pair, and I can use the law of sines. Now, I'm not sure what side you want to call this. I don't know, just call it an X for the moment. We can write this as sine of 10 degrees over 1550. It's going to equal the sine of 15 degrees over X. If you cross multiply, and you can do that because you got a proportion, this times this, I'll end up with X sine of 10 equals 1550 sine of 15. To finish solving for X, just divide both sides by sine of 10, and I'll end up with X equals 1550 sine of 15 divided by sine of 10. Put your calculator in degree mode, and that should be good to go. So let's see, 1550 sine of 15. Now here, I got to caution you. You got to close off that parenthesis there on the sine of 15, because otherwise it's going to do arithmetic on that 15. You just want the sine of 15, and that's it. Then divided by the sine of 10. Again, close parenthesis. 2,310.2, call it 2310. About 2310. Not bad. Now, does that make sense, given our triangle? Now, what the law of sine says is that these sides are proportional. In effect, that's saying the largest angle has to be opposite the longest side. The shortest angle has to be opposite the smallest angle has to be opposite the shortest side, and the medium and the middle are also going to be opposite each other. And that makes sense. This is going to be the shortest side. That's going to be the next side. This one's going to be the longest side. if you wanted to calculate that, you'd find that it's much longer than these other two. Are we good on that? Let's try another one. So if I was teaching this in a face-to-face class, and if you're taking exams from me in a face-to-face class, then you'd see something like this on a test, that I'd give you some things and I say, solve the triangle. Solve the triangle means find all the angles and all the sides. So this one looks set up pretty nicely to solve for A, B, and C, or excuse me, A, B, and B. So let's do it. Now, the one thing you know is one thing we've got, and that is an angle and opposite side pair right there. You absolutely need that if you're going to use the law of sines. So let's start out with that. It's going to be sine of 20 divided by 4. And then we'll pick this one because we have a known and an unknown, equals the sine of A over 5. If I multiply both sides by 5, I get 5 sine of 20 over 4. And let's do that on the calculator here. Clear that out, clear this out. So 5 sine of 20 divided by 4. Okay, so I get 0.4275, et cetera, 0.4275, and that's equal to the sine of A. But I want A, I don't want its sine. So what would I do to find A?
Take the inverse of that.
Awesome, thank you, Reagan. Take the inverse of that, so it's gonna be the inverse sine of 0.4275 equals A. And I'm really taking the inverse sine on both sides, but on the right-hand side, that inverse sine and sine cancel each other out. Now here's where it becomes a little interesting. For myself to do the inverse sine, I'll click this, second sine, second answer. That's going to give me the inverse sine. It's a nice, accurate way not to have to type in this number. And I get 25 degrees. Okay, that's fine. 25.31 degrees. But here's the catch. There might be another possibility. We're going to have to look. So what would that other possibility be? That other possibility could be 180 minus that answer. Actually, you know what? Before I do that, I'm going to just store this one. Store this. No, it's not the store key. Store, which is next to the number 1, in X. Just to have that around. The other possible answer for me would be 180 minus X. So it gives you 154.69. Or 154.69. The question is, do both of those form a triangle? Well, let's find out. If certainly I can squeeze in an angle of measure 25.31 degrees, so we're good there. But how about the angle of 154.69? Can I still form a triangle over here? Keep in mind, what does this have to add up to?
180.
Has to add up to 180 in both cases. Now, certainly I've got room to find another angle here. And I can also squeeze in a little angle here, right? If you take 180 minus that, 160 minus that, it's going to give you about 5.31. So a very small angle, but it can work. 180 minus 20 minus 154.69 5.31. If you're taking this in a face-to-face class on the exams, I always kind of duplicate the information. Kind of a subtle hint to let you know that you should be checking for 2 triangles. And that if you find 2 triangles, you don't have to copy all the information. It's already right there for you. In this case, we found 2 triangles. Now this one, let's see, my brain is failing me, so I'll just use what I've got stored in X. 180 minus X minus 20. Oh, okay, there you go. 134.69. So let's put that in as well. 134.69. And now I've got to use the law of sines one more time to find this angle, or excuse me, this side, and then likewise over this one. So let's see if we can't do that. I would work with this known pair to begin with. So it's going to be sine of 20 over 4 equals, you got no choice. You got to use this angle to get this unknown side, sine of 134.69 over b. Cross multiply and divide, you'll end up with b equals, the 4 will be in the numerator, the 20 will be in the denominator, 4 sine of 134.69 divided by sine of 20. Four sine 134.69 divided by sine of 20. 8.314, so call it about 8.31. Now we have to repeat that kind of calculation over here. See if we can't get the same thing. By the way, can anyone tell me, do they think side B is going to be larger than this, between these two, or smaller than this? How's side B going to stack up?
I think it should be the smallest.
Smaller.
Yeah, it should be the smallest because it's the smallest angle should be opposite the smallest, the shortest side. Over here, things line up perfectly, right? You've got the longest side opposite the largest angle and the smallest angle opposite the shortest side, and then middle and middle. So it should make sense when it's all done. If something is off kilter, it's wrong. Fix it. All right, so to finish this one up, then it's going to be kind of like the last one, sine of 20 over 4 equals sine of 5.31 over b. Solving for b, b is going to equal 4 sine of 5.31 over sine of 20. So I'm just going to cheat and edit my previous answer. I want 5.31. And there we go, 1.08. Nice. So are we okay on this one? That one's about as hard as they get for law of sines. Now you should always check for that second solution. Sometimes you'll find it, sometimes you won't. Now we wouldn't have got that in our first problem because our angles were too big. In fact, in our first problem, we were solving for sides, so it didn't matter. But sometimes this angle will be too big to work in your second triangle, so you throw it out and just use that first one. Comments or thoughts?
Would it matter if we used alpha, beta, gamma instead, or would we get marked down for that?
Oh, you quite the opposite. You might get bonus points. I like alpha, beta, and gamma better. I mean, I think that's
Okay.
probably what I use in my videos, but I was just keeping consistent with what my math lab did. But yeah,
Okay.
no, alpha, beta, and gamma, bonus. All right. Awesome. Appreciate that. Last question, last example, real quick. And that's going to be, let's see, this one. So we're going to have A is 7, B is unknown, C is 4, and A, B, and C is 120. So we have what we need from the law of sines, or to use the law of sines, and that is an angle and opposite side pair. So we dutifully set it up. This would be our first one. We'll do sine of 120 over 4 equals sine of A, which we don't know, over 7. So I'll multiply both sides by 7 because I want to get the A by itself, and I can start it that way. But let's see. Before I take the inverse sine, let me get a numerical value here for you. Sine of 120 times 7 divided by 4, 1.515, etc. Sine of A. And I'm going to stop here. Can anyone tell me why I'm going to stop here?
Because it can't be above 1.
Yes. It can't be above 1, period. Sine goes between -1 and 1. That's too big. In fact, if you try to do the inverse sine of that, you say, okay, inverse sine of my previous answer, and it should give you a domain error. Oops. And that's just screaming out at you that there's no solution. You can't form a triangle with this information, no solution. And what you should keep in mind is that when you're solving triangles, there's going to be 0, 1, or 2 possibilities that you can run into when you're using the law of sines. So, awesome. Anything else on this one? All right, let's stop it and get you back going.